Today, again, we have David Lepp, who will guide us through the technical part of this session. My name is Karin Patenga. I'm a product manager in the Oracle Spatial and Graph team. And in addition to David and me, there are several other colleagues on the panel or logged in as participants. They will help us to answer your questions directly during the session. And before we get started, I have some information about the session and also details about planned or recorded events. You can find the recordings of previous sessions in the Ask Tom app under Recordings. This is what you can see here. And the link you can see on the right side as a QR code, so you can directly jump into the app. We welcome your suggestion for topics for future sessions, and the easiest way is to simply send us an email, either to my email address or to the email address of my colleague Hans Fiemann. So we will see what you suggest us, and then we can prepare next sessions according to what you're interested in. For your technical questions about Oracle Spatial, I recommend two platforms which we monitor on a regular basis. The first one is Stack Overflow. Here you can please tag your questions using Oracle-Spatial. And the second channel is the Oracle Forum for database developers. The tag there would be just Spatial. In case you have not yet visited the Analytics and Data Oracle User Community webpage, this community regularly organizes either TechCasts or on a yearly basis, they also organize a summit, and the next summit will take place in April next year. The call for papers for this event has already closed earlier in November, and we are waiting now for the agenda to be published. And with regard to the TechCast, we had a very interesting TechCast in November with our partner SysTDI, which is based in Germany. This partner, together with Oracle Consulting, has realized a very nice and challenging project related to 2D, 3D data and publishing those data in applications that are available either to the client directly or to the clients of the client. So it's a very interesting project. The upcoming TechCast is with our customer Nibio in Norway and Johannes Ralph. He is a data scientist at Nibio. He will talk about a project where they have plenty of especially raster data, and he will present how they process raster data and what kind of insights they get from raster data. So stay tuned or register for that event. Okay, and the last thing is kind of housekeeping. Please post your questions in the Q&A box. We will try to answer your questions directly. I hand over to David.
All right, thank you, Karen. All right, so we're going to jump in, and the context of this session today is, in the most broad sense, it's around Oracle Spatial and sort of quote unquote lakehouse architecture, having a touch point that you can actually start and do some useful things with immediately. That's what I'm going to show you. And I also want to discuss where all this is going in the context of the Oracle database strategy around Lakehouse. So that's the context here. And because there may be a few people that aren't familiar with Oracle Spatial in general, I always like to kick off for about 2 minutes, just giving a very quick introduction to the Oracle Spatial context. So let's, Karen, go forward, and we'll just very, very quickly get that out of the way in case there's anyone here that's not already familiar. So the Oracle AI database is a converged database that supports many, many different forms of data and allows you to operate on those different forms of data centrally within a single database platform instead of having multiple specialty purpose-built databases that have to be wired together. So that includes traditional relational, columnar, graph, JSON, and spatial, and they're all first-class elements of Oracle's converged database. So with that in mind, whenever we talk about Oracle Spatial, all we mean and what we're referring to is the sort of collective set of geospatial capabilities that are just part of the Oracle AI database. And it's not a separate product per se. It's not something that you license and deploy and integrate separately. It's just simply the collective set of geospatial features of the Oracle AI database. So let's go forward from there and describe quickly exactly what that means. So you can go to the next slide. All right, so in its most essential definition, it means that we can store geospatial data like points, lines, and polygons, and you can see examples on the left of what those would represent in the real world. And we store those as a native type with a native index in the database in tables, just like any other tables in the database. And the purpose of doing that is to answer the kinds of questions you see on the right-hand side. So of course, it's nice to be able to visualize and look at your data on a map, but it's equally and even more important at the end of the day to be able to answer the kinds of important questions that you see on the right. And that's why we do what we do, is to be able to manage geospatial data so that you can answer location-based questions natively within the database. So next slide. Beyond that, we store many additional forms of geospatial data with associated APIs and frameworks for storing natively any form of geospatial so-called raster data, gridded data, satellite imagery, drone imagery, etc. Multiple forms of three-dimensional data, including 3D point clouds, which is the kind of data collected by LiDAR scans to form a 3D scene, connected networks for routing, and I could go slide by slide by slide with lots and lots of other sort of more advanced forms of geospatial data. But at the end of the day, it's about answering the kinds of questions you see on the right. So all these different geospatial features put together allow you to really represent any kind of geospatial information you have and answer the kinds of questions that are important to get from that data. So let's go to the next slide. And what this means in a practical sense, and it looks like, Karen, one of my red boxes on the right kind of floated out, out of its intended position, which would be on top of the SDO inside. But be that as it may, the most sort of hello world example of what that means is that you have a table, traditional table in the database, and you can have geometry as one of the columns in that table. In fact, you could have multiple columns storing different representations, spatial representations of data. For example, you may have coastlines at more detailed and more generalized scales and so on and so forth. And so it's just another column in a table. And when you store your data that way, you can use the SQL API to answer location-related questions about location relationships. In this case, we have a properties table on the left and then a query on the right that tells us which properties are within a predicted flood area. So the whole idea here is native storage of geospatial data and a very wide and very deep portfolio of spatial analytic and analysis operators and functions. Let's go to the next slide. And the other important dimension of Oracle Spatial is the open interoperable nature of it. So on the left-hand side of this picture, we see sort of the spectrum of Oracle tools and developer resources that all have first-class support for Oracle Spatial. So of course, working straight with SQL, but also working with Oracle Apex for low-code custom app dev, working with Oracle Machine Learning for predictive analytics, Spatial Studio, our self-service tool that I'll be using. All of these and more have first-class support for spatial. And on the right is the geospatial industry at large. And so we also have support and partnerships across the geospatial industry. Over on the right on the top is a little logo for Cardo, which is our newest partner, but we have lots of partners that have have grown over the years with us in this industry. So the picture here is meant to reinforce sort of the element of flexibility and agility when you're working with spatial. Kind of you can invoke and work with that data from many different directions. All right, so that's sort of the quick overview of spatial. And what I'm going to be talking about today specifically is getting into this sort of lakehouse sense, where the idea in lakehouse is being able to sort of separate data storage from the compute engine that does the work on that data. And so in a lakehouse, you'll have all different kinds of files stored in different formats that can be accessed by different data engines. And then you want to do useful work against that data. And because this is in the Oracle Spatial context, we want to talk about data, geospatial data, and geospatial data that would live in a lakehouse architecture. And one of the critical key, no, I was going to say emerging, but it's emerged as a pivotal geospatial format for lakehouse architecture is GeoParquet, and I'll say a little bit more about GeoParquet in a moment. But the idea here is that we want to be able to access data from object storage. I'm specifically going to be working here in an autonomous AI database context, and our lakehouse is files and object storage. Not yet, Karen. If you could go back up, I wasn't ready for that build out yet. So the idea is that we want to be able to access that data and do some useful things with it from spatial. So Oracle Spatial is the engine. The data is in this important, widely adopted geospatial format. And the straightforward way to get that started is to be able to create what Oracle supports as an external table against that data. And what that means is that you treat that data in files as the physical storage of table data, but you provide the Oracle database with all the information it needs to know how to access that data and represent it as a table. And once you do that, you can treat it like a table. So what we're going to do with GeoParquet in particular is note the way that it stores geometry. And the way that it stores geometry is in a standard type embedded in that file that we have support for in terms of the ability to dynamically convert that format to our native format. Because of the fact that we can convert the geometry in GeoParquet to our native format, that means that we can write SQL queries that include that on-the-fly conversion, at which point it's presented as a Oracle Spatial geometry. And then we can do whatever we want to do with it within our Oracle AI database engine in Spatial. That's what we're going to show for GeoParquet in particular, because that's the really critical, important format that's going to be actually a cornerstone of the broader AI Lakehouse iceberg arena. But we're going to start right now just treating this as a GeoParquet file in isolation. And I'll mention now that it's going to be the same idea that I'll show when it comes to working with files that have GeoJSON files, for example, that we can create an external table from, dynamically convert to geometry through just SQL queries or creating views that do that conversion, and then use the Oracle AI database as the sort of the compute engine for how we work with that data. Now that's what I'm going to show right now. Now you can build out, Karen, and the roadmap perspective of where all this is going, because I want to make it very clear here that there are limitations and important sort of caveats to understand, but those limitations are really just relatively short term as we emerge into what the real lakehouse architecture is going to look like with spatial as a part of it. Now you'll notice when I've got that arrow going from the object storage to the database, it says no indexes, and I highlight that because it's important. It's an important consideration. Oracle supports external tables. So again, defining a table against data that lives in files, very powerful, but you can't create an Oracle like index on an external table. So that's just a blanket limitation. That's not a spatial limitation. So that means we'll be able to access this data right now, but we're not indexing it. And so when it comes to performance, this is going to work nicely, and I'll show you an example with a relatively modest amount of data. We're not going to do that with a 957 gigabyte Parquet file and start to do lots and lots of quick ad hoc queries and drag and drop it onto the map, because it's not natively indexed. When you're working with smaller GeoParquet files or GeoJSON files, which would tend to be smaller, this is going to work fine. Now, I wanted to tip our hand in terms of where all this is going before I show you what's on the top. The direction for all of this is for this GeoParquet format to be, as opposed to what it is now, which is just a file that we can access and then process accordingly to make it useful and spatial. Well, the roadmap is, and what's being worked on, is to make GeoParquet a first-class sort of known format for data in our AI Lakehouse architecture. And what that means is that, Parquet files are supported for external tables, but today, like we'll show on the top, we can point to Parquet. It'll know how to work with that table, but it doesn't know that it's GeoParquet. Therefore, it doesn't know that there's a geometry that should be converted so that it can be used in Oracle. Well, the first important roadmap item that's being worked on is to have first-class support for GeoParquet. So when you point to GeoParquet, it's going to know this is not just any old Parquet file, it's GeoParquet. It's got a specific geometry format that we know how to convert, so that'll be turnkey. You don't have to do any of this conversion yourself. But the other, same really super important point is that it will be part of the other enhancement that's happening that we're working on is to leverage another aspect of GeoParquet that will make this scale. And that is the fact that within the Oracle AI Lakehouse architecture is the so-called Data Lake Accelerator. And the Data Lake Accelerator does a couple of things. First of all, it provides an additional series of resources. You can see underneath object storage, which is a whole series of virtual machines with that enable parallel data movement and avoid the bottlenecks of going through one thread to get all the data in and out. So you get the parallelization. But the other thing that it does that's going to be huge for us is that it supports predicate pushdown, sort of similar to akin to Smart Scan in Exadata, where filtering is happening down on the compute side. So you're not moving all of the data to the database like you are on the top picture. So specifically, the way that that's enabled, and that is being enabled, is that one of the specifications of GeoParquet is that there's metadata for every geometry that describes its bounding area. And because of that, anytime that we're going to have a spatial query in that bottom picture, we're going to be able to do a whole set of primary filtering based on those bounding areas down in the storage layer through a predicate pushdown using those bounding areas. So even if we have a terabyte of GeoParquet data and we're doing some spatial query on a small area, that whole primary filter eliminating 99% of the data is going to happen down in the storage layer, and then we'll work with the rest of the workload on that much smaller amount of data actually in the AI database. So those are the two things that are going to make working with GeoParquet and the AI Lakehouse with spatial turnkey from the perspective of recognizing it as a spatial format that will be automatically cast to Oracle Spatial, and turnkey in terms of performance when it comes to offloading predicates and parallelizing throughput. I'm going to show you the top part right now, and the bottom part is what is going to be coming out as we are becoming a mainstream feature, spatial becoming a mainstream feature of the autonomous AI Lakehouse. And the bottom, the AI Lakehouse is, I'm not going into that whole picture that has to do with data catalogs and so forth. And it fundamentally is about supporting iceberg tables as that open table format. And GeoParquet is going to be like the sort of a cornerstone geospatial format for iceberg tables. So again, that's sort of the where we are going. All right, so that's all the preamble, and then I think no more slides, and the rest of it I just want to now show you all this stuff I've been.
I stopped sharing.
Yep. So I'm going to
Okay,
share now.
you can take it over.
Yeah. So Karen, would you just confirm you can see my
I can't see your
screen?
screen perfectly.
And I'm going to go to chat because I'm going to show a couple of pages here that might be useful for people to see. So this is like, I want to back into the current picture, but back into it, keeping the perspective of where all this is going. So I've just put in like this George Lumpkin's blog about the Autonomous AI Lakehouse, which is important to understand in terms of where all this is going, to keep the context. Where the context is AI Lakehouse is having the best of what you do with data that's in Oracle tables in the database, lots of geospatial data, plus incorporating what you have in a data lake with iceberg tables, think GeoParquet, and being able to work with a variety of different engines, including accessing that data from the Oracle database, working with it within Spatial. So this is a good blog to give you that zoomed out perspective of where things are going. Now to kind of zoom in on the next step as we sort of drill down on the basic sort of demos and examples I want to show. What we're going to do today immediately is say, well, for right now, let's just look at that data in the object storage as our little sandbox lakehouse. And we just want to query that data as external data. And so there's a few steps in the Autonomous AI database to getting that sort of that whole thing set up. And I don't want to go through step by step all of that right now, but I will just point you to, and I'll copy some links in for the essential sort of documentation on what that looks like. And I'm starting here with this documentation page on just in general in Oracle AI database, querying external data, meaning data that can be actually in any of these locations, but we're focusing on data that's in object storage. So I just figured it would be helpful maybe in chat if I actually, I'm going to send these.
Put
Thanks
it
for sending
into the
that other
chat
one.
for everyone.
That's what I'm going to do. Thank you for that.
Yeah. Okay, you're welcome.
So this is just kind of the very first step in taking a look at what it means to query external data. They sort of talk about it, and then for the example that they give, we have this little toy set of 5 rows of comma delimited data. That's our hello world. And then so that's the data that we want to have in a file. Before we start working with other GeoParquet and so forth, let's just have a little text file and make sure we can make that work. When we are going to access that data as external table, one of the things that we're going to have to do is have a credential, which is essentially it's like a credential stored in the database that includes everything that's needed to authenticate the person creating the table and querying the external table, everything needed to authenticate it against that OCI object storage resource. So this is the file we're going to use. When it comes to setting up the credential, I will also put this link in there, and this is a link to the API for all the various programs or the sub-programs and procedures to create credentials and test the credential by querying, making a query to an object storage resource. So if we look here, there's a procedure called create credential. And if we look in there, there's create credential. And there's some different variety of different forms, as you can see, for how you do that. But the one that we use here is this guy right here using, we define a credential, give it a name, and then we have these so-called OCIDs are just the OCI unique identifier for any artifact. So we have a unique identifier for the user, for the tenancy, and then we create a private key and a so-called fingerprint. And that's basically it. Now it turns out that it's pretty straightforward to actually do all this once you know exactly where to look. And so just to have this little path here to the happy path, I think, to doing this, I'm going to log into my OCI account. Of course, I got to do this. Just stand by. And okay, see if sorry about that. I have to find my authenticator app. Do, do, do. This again. This. All right, minor malfunction here. We'll get there. I'm just the authenticators. I'm trying to get the authenticator to come up so I can approve it. Hopefully this time. See, that was easy. Well, we're out of time now. Thanks, everyone. Okay.
Always a challenge.
Yeah, that was yeah, that was
a minor challenge.
That wasn't my smoothest moment. All right, so again, this is the form that we want to use, where the credential name is just some friendly name that I'm going to give for this credential that I'll end up using when I'm going to create an external table. I'll refer to the credential. But we have user OSID. We have these. I don't need the comments, but we just have these 4 things that need to be included. And so here's where you get them. So if we go to now that I'm logged into OCI, go to my user. And if I go to tokens and keys, and here's where I can add an API key if I want to. So I generate a key and then I can download it. And in that downloaded key, I'd actually have this whole long key string that I'm going to have to use. And I've already done that. So I downloaded my key. And here's the key that I created. Now here's the kind of the trick, if you will. If you come in here and say view configuration file, here it is. This is, these are the parameters that you need to add. So remember I showed here, it's a name that I'm going to give my credential, and then it's the user OSID, tenancy, key, fingerprint. And if you come here, there's the user OSID, there's the fingerprint, there's all the stuff you need except for the key. And you can either point to the key file that you downloaded, or you can actually paste in the whole long key value itself. So that's a convenient way to get all the parameters you need. Of course, you can also one by one get the values yourself. For example, the first parameter is the user OSID. You can copy it from here. The second parameter is the tenancy OSID. You can go to the tenancy and grab the OSID here, et cetera, et cetera. But by going to tokens and keys and adding a key and viewing the configuration file, it's sort of that's the happy path from my perspective. All right, so that's like kind of step 1. Then now that I've got a key, I've created a credential. I called it like OCI cred for OCI credential using SQL. All right, so now I want to have some files to work with, and I didn't want to have you watch me upload files to object storage, but I'll just show you. And Karen, you can still see my screen.
I can see it.
Okay,
sure.
Good. Thank you. All right, so I'm going to go into my own storage bucket here. And in my storage bucket, I'll look at the objects that I have. And here's these objects that I have. I have like 5 files. So it's the last 3 here that are just sort of for this example here. This test.csv, that's just the CSV file That's this data right here. Copied and pasted that into a file and loaded it to object storage. That's test.csv. I also have a test.parquet file, and those are OpenStreetMap building footprints for the US. And then I have a file test.jsonl that's like a GeoJSON format that I'll talk more about in a few moments. But the first thing we want to do, okay, here's our little hello world example. So now to work with that data, Karen, just confirm now, hopefully, are you seeing my SQL Developer?
Yeah, I can see SQL Developer inside
Okay.
Visual
Yep.
Code.
So anyone that's still using the SQL Developer client, like the thick client standalone SQL Developer, I highly recommend you switching to using SQL Developer and VS Code, because that's like really the direction, that's what's being worked on and updated now, and not the thick client. And there's all kinds of great features, and it's very stable now, and it's great with spatial because it supports showing spatial types. So highly recommended. All right, so now first thing I want to do is just run a little test to make sure that my credential, this is a credential I created with the create credential SQL command, using all the parameters that I just showed you, the OSIDs and the fingerprint and all that stuff. And that DBMS Cloud package that I showed you has all kinds of procedures, not only creating credentials, but also then using those credentials to do things like list objects in a storage bucket. So here's the storage bucket URI that I just showed you. So where do I get that from? Well, if we go to the bucket, if I was to look at maybe look at one of these objects, and here's the URI for the storage bucket. So if we come back here and just use that to do a listing. So this is just using SQL to show me, using that credential, what's in this bucket. And it's, no big surprise. So now I see that one of the things is that test.csv file. So a little hello world is to create an external table pointing to that CSV file. So this is kind of like a reproducible test script. I've done it before. I'm going to make sure I drop whatever I had done previously. So here's where we create an external table pointing to that file. So I'll give a name to that table for the Oracle database. That's going to behave just like a table. I have to supply the credential name that I created, the file URI. I just showed you where to find that. And then the format. And the format is the format is provided as a JSON string. I'm just, by default, or not by default, in the doc, the examples just show you using this JSON object function, which you could similarly just put JSON in here. And it's a key value, where here the key is delimiter and the value is what is the delimiter. So this just means it's a CSV file. And then I'm declaring here what the column types should be for the columns in that CSV file. So if I run that, I've got that procedure, and now I could just select from that table, and that's an external table, So now I could do whatever, I could do my select distincts, and I could do joins and counts and analytics equal, whatever I want to do now. This is just now a table. So as soon as we do this, we start to say, now what if there's some geospatial content and it's just a table and we could do interesting things with it? So let's now look at that. So I'm going to drop what I had done previously to create this table, and I'm going to recreate it. So now I'm going to create a table called test parquet, and it's going to be this GeoParquet file, the same credential. Now parquet files are well, you know what I actually meant to do before I do this GeoParquet is put another link or two in the chat. So it's worth getting a little bit familiar, if you're not already, with Parquet and GeoParquet. Parquet, the Parquet format in general, is this highly optimized columnar format for this sort of purpose, for like an open table format. And GeoParquet is this standard now for working with geospatial data in Parquet files. And so I'm going to put this link into in here for everyone to check it out. And so in the data lake architectures, GeoParquet is like the predominant format for data of any significant volume. So if we take a look here at the specification, if we take a look at the specification, you're going to see here the specification talks about what has to be in there. Geometry columns, very interesting here. Geometry must be encoded as WKB. WKB is well-known binary. That's one of the standard, industry standard formats for a geometry. And of course, we provide SQL functions for converting to and from WKB. So since Parquet is supported and GeoParquet has WKB, and we support WKB conversions, the wires touch. And, for right now, I'm going to be doing the conversion myself with SQL, but think back to what I said about how we'll be adding first-class support so that that's a recognized format, and all that conversion and stuff to make it surface as Oracle Spatial content is going to be turnkey. The other useful link that I'll put in here is this blog that talks about the GeoParquet format, and I think it's a very interesting read, and it gives you a good sense of the importance of this format and why we're paying so much attention to it. All right, so back here now, the Parquet format has metadata. One of the reasons that it's so well suited and built for Lakehouse architectures for open tables is that it actually is self-describing. There's headers that describe what the content is and what the types are. Unlike just a CSV file, I can say for the format, all I have to say is it's a Parquet file and basically read the schema of that file from the header. So I don't have to know ahead of time. I can sort of discover the schema. So I'm going to create that table, and then we'll see what is in it. What do we have? So here's what's in that table. So it's a table that has, now remember, these are building footprints. So it has the area in meters, the confidence plus code is sort of a universal addressing scheme for a unique ID for each address, but it's there. It's a format that's great because it even supports unique address identifiers for places where there is no proper address out in the small rural villages and anywhere in the world there's a unique plus code for an address. The geometry is a blob, but we know that's a well-known binary format. And then there's this quad key, which is a way of sort of if you know about the H3 index for creating hexagons at different levels of resolution, each has an ID. Well, this is the same thing for these rectangular areas. So it's just a way of indexing a footprint somewhere on the Earth, and then the country code. So that's what I have in that file. And we'll take a look at a few rows of it. So here's a few rows of it. The area, the confidence, this is this unique ID for a building. The geometry is well-known binary, and the quad key. So now, because this is just a table in the Oracle database, we can use an Oracle SQL function to convert the well-known binary to SDO geometry, our native spatial format. And I'm going to say I know that this is going to be 4326 is longitude, latitude. So I'm just going to select some geometry. So here are, the first 9 property geometries in SDO geometry format. So once we can do that, I can pick. Now remember that there's no indexes on this. We're not doing that predicate push down, data lake accelerator, all that sort of stuff yet. We will, but for right now, I want to just slice out a small enough portion of this data that I'll be able to work with easily and visualize and so forth. So I'm picking a quad key. This is somewhere in Southern California, and I want to see how much data is in this. And so there's 16,000 buildings in this area. That's a reasonable amount compared to working with millions and millions right now when there's not going to be an index. So what I'm going to do now is create a database view. and that database view will just be selecting some columns and a for a particular quad key. So before I do that, I'll just run the SQL statement that will be the definition of the view. So I just want to pick a couple columns, and I want to convert the geometry to SDO geometry for one particular area. So this would be my little sample data, and I'm going to call that view buildings GeoParquet. So I'll create that view. I'll describe the view. And so we can see, just as we expect, it's got the two columns, the plus code, this a unique ID, quad key, and a geometry. So now that that's done, well, let's just take a quick look at that data. So now here's the contents of our view as we'd expect. Now this is, now we're working with that data. There's all kinds of things we can do that we have now a handle on that data in Oracle Spatial. We could start to do spatial queries on this data because as far as Oracle database is concerned, this is just now a table, just happens to be pointing to a GeoParquet file. We had to do a few steps, but those steps are going to get alleviated and simpler as I said, become part of the AI Lakehouse sort of first class file type. So the other thing I want to do next is because I want to work with these data in different tools like Spatial Studio, maybe Apex, maybe OAC, etc. Those tools will tend to look for spatial data by checking the spatial metadata table. That's what Spatial Studio and other tools do. So I want to add a row of spatial metadata for this view. Now, normally you put that metadata in oftentimes because that's part of what a spatial index will look at. We're not going to have a spatial index on this. Remember, we're not indexing it, but we do want to have the metadata there so so that it's discoverable as spatial data. So just to reset, because I had done this previously, I'm now going to insert a row of spatial metadata for that view and save it. So now from the perspective of getting access to that data, I can start to do spatial queries here at the command line and do some things to show that works. But what's probably more interesting is let's just work with that in a self-service tool like Spatial Studio, of course, and see that it behaves just like other spatial data. So I'll go to Spatial Studio.
David, can I stop you for a moment? There is a question in the Q&A box. Somebody is asking from which version for which services or editions is GeoParquet supported. Maybe you can just briefly answer on that one.
Well, it's supported. So this is not it's not a matter of spatial supporting or supporting the GeoParquet format. The only support requirement is external tables supporting Parquet files. So maybe one of my colleagues could see when, at whatever version of the database, a Parquet file is supported for an external table. That's all we need, because once we're working with a Parquet file, the rest is us just converting the geometry and working on it from there. Now, when I talked about the roadmap and the AI Lakehouse and having first-class support for GeoParquet as a known type, where all this stuff happens automatically, I mean, that's where I would really consider first-class support beginning, and that hasn't begun yet. We have the support now that works for any database environment that where an external table works against a Parquet file. So again, I don't know if that was I mean, I'm going to say like 19. I'm going to assume 19, but maybe a colleague will tell me. And I'm also focused on autonomous database and OCI object storage, and that's thinking about the Oracle Cloud Lakehouse architecture. But again, as long as you can connect to a Parquet
we will
file,
recheck it and get back to it.
Yep. All right. So now I'm in Spatial Studio, where I assume most folks have seen Spatial Studio, but if you haven't, this is our no-code tool for working with data in Oracle Spatial, even external tables that are spatial, as well as data coming from standards-based services. And it allows you to connect to the data, load it, prep it as needed in geocode addresses and do things like that. and then do drag and drop mapping and drag and drop sort of spatial analysis. So that's what, and just some examples of what projects look like when you're doing all this sort of stuff. So it's just self-service, no-code tool. So now I'll create a couple of data sets. So that just means I want to point to some data that I want to work with here in this environment. And I'm going to go to my connection. This is the database that I've been working in. Now I already have a table, not the GeoParquet table, or not the external table that I just showed, but I have a table in the database. This is now not GeoParquet. This is just a table in the database that's very fancy. It has one line. But the point is that this is a table in Oracle Spatial with some content in it, because I want to show how we can work together with GeoParquet and data in the database and sort of work with them together. So I'm going to create a data set that points to this table called hazard line. And you'll be shocked to see that that line just happens to go right through this area of buildings that we're going to work with. And when we create a data set like this, I should have specified that it has an ID. All right, so now we've got this data set called hazard line, points to a table called hazard line. Then I also want to connect to something else from this autonomous database. But it's not a table, it's a view on that external table. And this is the view that we just created, view buildings, GeoParquet. And the reason it has a pin there in that listing is because it found it in the spatial metadata. And that's why I added it to the metadata, so that it would be recognized as a spatial table, even though it's a view. So I'm going to assign the key. I know that quad key is a unique, not the quad key, the plus code is the unique identifier for every building, and I'll validate it and accept it. So now here it is. I mean, we have a what looks and behaves and is treated like an Oracle table, but it is a GeoParquet file and object storage. So I'm going to grab both of these guys, create a project. Whoops, create a project. Now I have these projects in there, and we'll drag and drop this in. Now this might take 30 seconds or something like that. So remember, this is now coming from a view. It's a query, and the query is based on that quad code, and there's no index, and it's like it's United, all like US buildings in OpenStreetMap. So this is where you can immediately understand how, as soon as we're part of that lake house, and there's each building MBR is part of the predicate pushdown, and all this sort of stuff will be, this kind of stuff will be much, much, much quicker. So this will take, like I said, maybe about 30 seconds. And in the meantime, I think I will also add this hazard line. This is the hazard line. And we promise this is going to come up. And I better make sure that I don't have a problem, because this actually comes up a little quicker than this. But if I do another select here, just make sure this view is happy. There it is. Let me just do a quick refresh here. Okay. All right, so this is the GeoParquet file. Again, all the OpenStreetMap building footprints in the United States with a predicate and no index. And so that's why, like, if you've got a kind of a small GeoParquet file or something that's at least, less than a couple, I don't know, less than a couple hundred megs or something, I mean, that's going to operate much, much quicker. But now that we have this here, we're actually dynamically caching the vector tiles for this. So this is now going to work, smoothly at this point, but again, this is straight from GeoParquet. So let's just do a couple things. First of all, to visualize this maybe a little bit nicer, let me say, I'll just make these things a little bit thinner. And to highlight the content, the data versus the background, I'm just going to switch to a more subdued background. And then just to make sure that we have the values that we think we have, let me just create a tooltip that will be that little plus code. So now you can see as I cruise around here, these are the plus codes, the unique IDs of every building in that GeoParquet file. So anyway, that's all fine. Now we've got our hands on this GeoParquet data. So now just to do something quick with it. So here's this line that I created, and just make it a little bit darker. So now we want to do some, I'm calling it a hazard line. There's a big storm coming, so that's this kind of the idea here. So just to show that we can do some sort of analysis with this, if I now say I want to do an analysis on my GeoParquet data, whoops, I don't want to do settings. I want to do a spatial analysis. Now, for people that haven't seen Spatial Studio, when I say spatial analysis, this is a GUI on the Oracle Spatial SQL API to do all kinds of spatial computations and measurements and spatial relationship analyses and so forth. You could do all this with SQL yourself if you wanted, but you can also use this GUI to do it. So what I want to do is return shapes within a distance of another. So I want to look for whoops, buildings within distance. I'm going to say within 500 meters of that hazard line. So I want to filter down all the buildings to only those buildings that are within 500 meters of that line. So now this is just Oracle Spatial, an Oracle Spatial SDO within distance query being run by Spatial Studio to do a proximity query. And here's the result. And we can drag and drop that in. And I can maybe change the color, something different. And all right, so that swath of buildings, so that's now an Oracle Spatial query, the compute engine, if you will, the spatial, like the database computing engine is Oracle Spatial in the database. The content is GeoParquet. That's the sort of the lakehouse. Now, this same GeoParquet file could be in a data catalog, and lots of other tools and compute engines could be connecting to it at the same time to do other things with it. Open table, sort of open data format. So just to take this one step further, let's do another analysis here, and then we'll measure, and then let's calculate the distance between things. So let's say building distance, and it'll be result with the distance. So I want to know the distance between just those close buildings and that line. I don't want to calculate the distance for every building everywhere. I only want to figure out how far away are the ones that are nearby where the units are in meters. So now this is showing that this is now like a nested query, if you will. We're doing a query of the previous query, first filtering and then doing a distance query. So I'll sort of get rid of that now. And now let's look at those buildings with their distance. And now this time, let's say, I'm not going to want to outline, but let's make the color based on that distance result. And so building distance settings, whoops, single color based on data, based on result. And then maybe I'll make the palette, just if I've come this far, I might as well do it right. And then now maybe I'd want to come here and I might even want to take all these buildings and kind of subdue their color. And now we're sort of showing a quasi heat map, if you will. But, and now, of course, I mean, this is just data now. If I go back to my data sets now, these buildings here with their distance and within distance and all that sort of stuff, this is now data that I could export. I can provide a GeoJSON endpoint to all the stuff that you would do in Studio, all the stuff you would do in Oracle Spatial. It's, we're sort of, this is what I mean in terms of us having sort of a touch point to that Lakehouse architecture. Now, we're approaching the top of the hour. This was the GeoParquet example. At the same time, we also have similar capability to work with other file formats like JSON data. So an example of that would be, I'm going to do the same thing I did before by getting rid of something I had previously. Now I'm going to create an external table to another file that's in my bucket, and that's a test.jsonl. JSONL is a really powerful and valuable GeoJSON format, which instead of being a GeoJSON document as a feature collection with opening and closing tags, it's just line delimited GeoJSON features. And that's a format used by lots of tools. Mapbox uses that, and other tools use it as an efficient way to serve GeoJSON that can just be streamed without having to read the entire document up front. So I'm going to create an external table to that. And if I take a look and describe that table now, it's just one field with a GeoJSON string. And here's what the data in that file looks like. So row, 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 each row is a GeoJSON feature with geometry, and down at the end, you can't see our properties. So now it's a little bit different than we did with the GeoParquet with the well-known binary. Now the beauty of working with this format is that it's JSON, and Oracle is great at working with JSON, all kinds of native JSON functions like JSON value to be able to extract properties and geometry from a JSON document. So now I can just take this external table and run a SQL statement using JSON functions. And now I've got the property as a column and the geometry as a column. Now I could create a view just like we did before with the GeoParquet on that. And then we could then I could select star from that view. And now we have exactly the kind of view that we had on the GeoParquet file. I could now do the same thing, go to Spatial Studio, connect to that view, add its metadata. And so we focused on GeoParquet because that's the real strategic format for the Lakehouse architecture. And this is what we can do today. And all the Data Lake Accelerator, first-class support for GeoParquet, that's going to make this really production ready. But this is today, currently possible and useful. So, lots of really cool, exciting things to come, and some pretty interesting, useful things can be done right now. So I think that's the top of the hour, Karen. I don't know if you had any closing slides, so I should stop sharing, or
yes. Thanks again, David, for taking care of that topic and planning it and showing it in the demo. The next special office hour is planned for January next year, so we will not have a special session in December because it's the end of December where hopefully everybody is on vacation, taking some time off. So January 27th is the next office hour. And just to remind you of a few resources, I put together the links here for the documentation, for the spatial blog, Binary Place, where you can find those forum, also our LinkedIn group for spatial and graph. So everything you can find here. And that's the end of it for today. Thank you very much for your interest and attention. And especially thank you, David, for putting the content together and explaining it to us today. Thank you and have a nice day, everybody, wherever you are.